Assalamu alaikum. My dear students, now we will discuss one of the most important topic of base catalyzed condensation reaction, which is called Aldol condensation reactions. So these condensation reactions lectures were taken from the book which names Principles of Organic Synthesis, which is available on internet. So Aldol condensation reaction, what is Aldol condensation reactions? The condensation reactions between the two molecules of aldehydes or ketones or aldehydes and ketones may be different or same. This reaction is called Aldol condensation reaction. If the reaction takes place under base, this is called Aldol condensation reaction under basic conditions. And this Aldol condensation reaction can take place also in acidic conditions. So acid catalyzed condensation reaction we'll discuss later. So what are the Aldol condensation reactions? If two molecules of aldehydes or ketones or aldehydes and ketones react with each other to give you a product, this is called the Aldol condensation reaction. This is one of the best and most important method for the formation of the carbon-carbon bond. This reaction gets its name from the dimerization of acetaldehyde, which was taken by a scientist named Wirtz in 1872. This scientist first of all made a product from the dimerization of acetaldehyde. The product name was Aldol. So this type of reaction is called Aldol condensation reactions. I will give you the mechanism of this reaction. The Aldol condensation reaction consists of 3 steps. So we will start with the acetaldehyde. For example, in first step we have acetaldehyde. So when you treat with the base, this is in reversible reaction. So base will remove the proton and you will get the carbene ion in the first step. In second step, this carbene ion react with the second molecule of acetaldehyde. This negative charge attack on the carbonyl carbon and you will get this one. And in the third step, the next charge comes on oxygen. In the third step, this negative from here, the proton is removed. This proton is abstracted by this oxygen and you will get this. So this type of product is formed. You can see that this product has 2 types of functional groups: oxygen, carbonyl and hydroxyl group. So because this contains also an aldehyde, also hydroxyl, this type, the product name was aldol. So all these reactions in which an aldehyde will attack another molecule of aldehyde or ketone to make a bond, these type of reactions is called aldol condensation reactions. Here in this case, we can see the rate of reaction will depends upon the 2 molecules, and in this case the formation of carbene ion is the slow step. When you carry out the reaction with aldehyde, you can see the rate of reaction is the slowest, will depend upon the first step, which is the slowest step. It means the removal of proton to make a carbene ion is the slowest step, and after that this carbene ion will attack on the carbon in a fast way. So rate of reaction depends upon in the first step. However, when you carry out the reaction with the ketone, then there is some difference, as we can see. Now I will write the mechanism of ketone. We have this ketone, first step. So when you treat this one with the base will abstract a proton similarly in similar way from one of the active methylene. In the second step, this one of the active methylene react with second molecule of ketone, this one, and negative charge comes on carbonyl group, oxygen. And in third step, this will abstract the proton which was released in the first step, So this type of product is formed. Product is same. In this case, one we have the keto group and one hydroxyl group. So product has two type of functional groups. Now, what is the difference? Here in this case, the formation of carbene ion is not a slow step, it is a fast step. But actually the attack of this carbene ion to the carbonyl group is the slow step. It means the second step is the slowest step and the rate of reaction depends upon the second step. Why it happens? It happens due to the two reasons. Why? Because the attack of this carbene ion on the keto carbonyl is very difficult. So due to this reason, this is the slow step. The attack of this carbene ion to this carbonyl group is the slow step. It is very difficult to attack due to two reasons. Number one reason is when you have two methyl groups attached to carbonyl group, and in case of aldehyde we have attacked one methyl group. So one reason is the electronic reasons. These two methyl groups, they are donating the electrons to the carbonyl group, so the partial positive charge of carbonyl group is decreased. So in case it means that the positive charge in case of ketone here is less as compared to aldehyde. The aldehyde carbonyl group is more positive as compared to the ketonic carbonyl group. One reason. The second reason is steric hindrance. In case of the ketone, the attacking nucleophile negative charge when come a tanic methyl group when attack on this carbonyl group, it is very difficult to attack due to two methyl groups due to steric hindrance. But when this negative K9 carbene ion advanced to attack on this carbonyl group, it is very easy to attack because we have only one side methyl group, other side is empty and it can attack. So due to those two reasons, electronic factors and steric factors, the carbene ion attack on the carbonyl carbon of aldehyde is easy, but the carbene ion attack on the carbonyl carbon of ketone is difficult. So due to this reason, the mechanism rate is different. Rate of reaction for aldol condensation reaction for aldehyde depends upon the first step is slow, but the rate of reaction for the aldol condensation of ketones will depends upon the second step, which is slow, which is the attack of carbene ion on the carbonyl carbon. Here, the removal of proton from to form a carbene ion is the slowest step. It is a general feature of the aldol condensation reaction.